Hi everyone, this is Sharan here. Today in this video we are going to see about 5 more interesting questions that are most commonly asked in data science interviews and what is the objective behind those interviews from the interviewer point of view and what should be your response for those questions. So the first question for today is what is precision and recall and what is the difference between them. So here the objective from the recruiter point of view is to understand whether you understand what is precision and recall. So this is very important because the term is very confusing. A lot of people confuse what is precision and what is recall. And if you clearly understand what it is, then that will create a huge positive impact on the recruiter. So next time when an interviewer is asking you what is the difference between precision and recall or what is precision and recall, what you can do is you can come up with a simple example. So let's say, so what I'm going to do is, let's say I'm going to take up a problem of predicting apples. So when I take precision, what it means is how many apples I have predicted correctly out of the total number of apples I have predicted. Let's say I am predicting like 100 fruits out of there are 100 fruits. Let's say what I am doing is I am predicting 60 of them are apples. Let's say I am correctly identifying 50 apples. So what is precision is? Precision is how many apples I am currently identifying, which is 50, out of the total number of apples I am predicting, which is 60. So 50 by 60 is the measure for precision. So that helps you to identify how good your precision is. On the other hand, recall is how many apples I am predicting correctly and how many apples in total are present in the actual data set. So let's say there are 70 apples that is actually present and there are 30 oranges. So I'm able to predict 50 apples correctly. So the measure for recall is 50 by 70 because there are 70 apples in total and I'm able to predict 50 of them. These two measures are really important because there are situations where it is important to ensure the precision is high, and there are other scenarios where it is important to ensure that the recall is high. There could be some scenarios where it will be important to ensure that both precision and recall are high. So depending upon the objective, we need to work towards the goal. So it is important to understand what precision is and what recall is. So next time when someone is asking you what is precision and recall, pick up a simple example and try to explain them using an example. This ensures that you have good clarity about the concept that you are talking about. The next question is what is an overfit? So overfit means that the model that we have, our model that we have built works extremely well on the training data set, but performs really bad on the test data set. So what it means is, it means that there are some noise that is present in the training data set and our model is picking up all these noises as patterns, and hence it works extremely well on the training data set, but when it is being thrown, when we throw a new data set into it, it fails terribly because it has picked up the noises as patterns and it is not picking up the actual patterns in the data set. So that is what overfit is. So next time when someone is asking you overfit, you try to explain what it is. Like overfit means that the model is performing extremely well on the training data set but performs really bad on the test data set, and the reason for it is because it is identifying the noises as patterns in the data while it shouldn't be identifying the noises as patterns. That is overfit. The next common question is K-fold cross-validation. So K-fold cross-validation is a technique that helps in avoiding an overfit and improving the performance of the model. So when an interviewer is asking you what is K-fold cross-validation, he is trying to understand whether you have used this technique, whether you understand various steps involved in it. So your response should start with a definition. K-fold cross-validation is a resampling technique that helps in avoiding an overfit. So how it actually avoids an overfit? Like we need to go through the various steps. So explain the various steps. So first step is ensure that the entire data set is randomized. So if you have 1000 records, all those 1000 records should be randomized. Then identify the value for K. So if it is an 5-fold cross validation, then what happens is the training data set is divided into 5 different groups. Then what we do is we pick up the first group, set it aside, and train the model on the remaining 4 groups. Then what we do is the trained model is used to predict on the test data set and we see how good the model is performing. So then what happens is we go to the second group, we set it aside, train the model on the remaining groups, and then test it on the tested group. So this process continues for each of those 5 different groups, and we take the average of all those predictive models, that all those training models, and then we use that averaged model in order to make the final prediction. The next question is, what is regularization? What are all the different methods that are used for regularization? So when someone is asking you what is regularization, so the first one is to start with what is regularization, like what is the purpose of regularization. So regularization is a technique that helps to avoid an overfit. So what is regularization? So what it is trying to do is it will try to penalize the feature which has the highest coefficient, and hence what we are trying to do is we are trying to simplify the complexity of the model that we are going to solve. There are 2 different approaches for regularization, commonly used approaches. One is the L1 regularization or lasso regularization. The second one is L2 or what we try to do in case of L1 regularization is we try to have a non-zero coefficient in case of features that are significant, that helps in improving the predictive results, and we use 0 coefficient on features that are insignificant, that is not helpful in improving the prediction. Moving on to the second approach, the L2 regularization or rich regularization. So here in this case, what we try to do is the technique forces to have smaller coefficient for all the features. So here in this case, in case of L2 regularization, we are not having any 0, so we are not removing any feature that is insignificant. So if there is a feature which is insignificant, what might happen is the coefficient will be extremely small but not equal to 0, and the coefficient for attributes or for features that helps in the prediction will be slightly higher as compared to the insignificant ones. So regularization, what it tries to do is it tries to identify the features that have highest coefficient and penalize them to ensure that the complexity of the model has been reduced. So in case of L1 regularization, let's say we have 10 different features. If the model identifies, let's say 4 of those features are insignificant, so then the coefficient for all those 4 will become 0, and hence the equation reduces. Like the number of attributes that will be considered would have been reduced. So what we are trying to do is we are achieving here by what we are trying to achieve is we are trying to reduce the complexity of the model here in case of the regularization approach. The final question for today is, what is boosting and batting? What is the difference between them, and how these techniques help in a data science in solving a data science problem? So here the objective of the recruiter is to see if you understand the concepts clearly, like what is an batting approach, what is the boosting approach, whether you know what are all the various steps involved in both the batting as well as boosting, and if you know about the various examples where these techniques are being used. So then what you do is you start with the first one, you start with the batting approach. So first, coming to the batting approach. So in case of batting approach, what we try to do is we first try to randomize the data and create different subsets within that data set that we have. Let's say we have 10,000 records. So what we try to do is we randomize all those 10,000 records, and let's say we try to come up with the different subsets, like 1,000 records, 10 subsets with each 1,000 records. So then what we try to do is we use those 1,000 records, and then we try to build a model, and we repeat this for each of those subset, and we try to take the average of all those models and then make the final prediction. So in terms of batting approach, what we are trying to do is instead of using the dataset as a whole, we try to use different subset. That could be some overlaps when we create all these subsets. There could be some data points which is present in like multiple subsets. So it need not be very distinctive. Like there could be some overlaps. So here the objective is we try to create like many algorithms as possible using different subsets of data, and hence what we are trying to do is when we average out the performance, or when we build a model based on the averages, we are trying to avoid the overfit. So we ensure that it is averaged out, and hence the performance or the accuracy is much more better. A classic example for batting approach is random forest. So in terms of random forest, what we try to do is the random forest tries to build a different decision tree. So how the different decision trees are built? So one of the approach is Badin approach. So we use different subsets and then create the tree and along with the different subset, what the algorithm also tries to do is it will try to create different subset of the various features. Let's say we have 10 different features, so maybe for the first tree it will use 7 of those features and a subset of data in order to make a prediction, and next time maybe it will use 5 of those features and different subset to make the prediction. So each of these trees are using different data as well as different features, and hence they are not correlated with each other. So when we try to average the model from all these, the accuracy of that particular model will be better than having just one model. So that is what a Badin approach is. So this is what you need to explain in your interview. On contrast, what is boosting? So boosting is also an approach that helps in improving the accuracy of the model, but how it works. So in case of boosting, what we try to do is we first start with equal weights for all the observations. So let's say when there is 10,000 observations, so we start with equal weights. We use all those 10,000 observations with equal weights, made the prediction. So there will be a small subset, or there will be a subset where there will be some records where the prediction went wrong. So what we try to do is we increase the weights for the observation that has been failed, and so then what happens is those cases where the prediction failed will have more weightage as compared to those records where we were able to predict accurately. And then again we build a model and we try to make the prediction again. So then from here, from this particular data set, we again pick up the records or pick up the data point where we have failed. So we increase the weights further, and we repeat this process until we reach the threshold of maximum number of iteration, or until we are able to accurately predict all the values correctly. As compared to Badin, so this technique is quite different. It is actually increasing the complexity of the model. So we are trying to start with equal weights, but depending upon the areas where we are going wrong, we are increasing the weights for those observations, and hence the process gets repeated. So an example for the boosting approach is AdaBoost algorithm. So this AdaBoost algorithms makes use of the boosting technique in order to improve the accuracy of the model. So that is it for today. So we have covered 5 commonly asked data science interview questions, and we have covered what should be the response for these questions. So what I would suggest is, maybe after going through this particular video, spend some time in understanding each of these concepts, because these are all the concepts that are most commonly asked in any data science interview. I hope you have learned something new from this video. If you have learned something new, please give a thumbs up and subscribe to my channel. If you think this might be helpful for any of your friends, please share it with them as well. And bye for now. See you in the next sessions. Yeah.